All right, let's dive right into this explainer. Today, we're going to break down exactly how a meticulously structured 12-rank curriculum can take a 5-year-old absolute beginner and transform them into an 18-year-old tech visionary. The wCode architecture we're looking at spans 48 unique badges across 7 major domains of technology, so it creates this unbroken chain of learning spanning over a decade. It's a roadmap that doesn't just teach kids how to use technology, but rather how to completely bend it to their will. Here is our roadmap for the breakdown. We'll start with a high-level look at the 12-rank tech journey, then we'll move chronologically through 4 distinct age divisions: early makers, junior innovators, middle explorers, and teen visionaries, before wrapping up with the ultimate graduate profile. So, let's kick things off with Section 1, the 12-rank tech journey. Moving right into Section 2, we have ranks 1 through 3, which make up the early makers division. Now, across these first 3 years, students aren't touching text-based code at all. Moving through Year 1 Spark, Year 2 Builder, and Year 3 Creator, the focus is entirely on building essential mental models, and they do this using physical programming, visual blocks, and digital storytelling. I am a thinker and a maker. This guiding theme really anchors their early growth. They go from solving physical puzzles with a screen-free code-and-go robot mouse to actually animating their own digital stories in Scratch. By physically pushing sequences into a plastic mouse or laying down tracks for a logical road builder, 5- and 6-year-olds are learning debugging and algorithmic thinking before they even know how to type. It's actually incredibly clever. And the output by the end of rank 3? It's remarkable. Just picture an 8-year-old confidently standing up in front of a room to present a multimedia digital story that they animated and narrated themselves. Then they choreograph a coded Sphero-Bolt robot performance and proudly show off a physical 3D object they designed in a browser using Tinkercad and printed in-house. Which brings us to Section 3, ranks 4 through 6, the junior innovators. During years 4 through 6, navigating the coder, engineer, and innovator ranks, the training wheels totally come off. Real programming begins here. This is that critical bridge phase where the curriculum shifts from teaching the broad concepts of code to the actual syntax of professional languages. Guided by the theme I code, I build, I create, visual blocks are rapidly swapped out for Python. This is where physical machines finally start responding to the students' actual written code. They start out by wiring up everyday objects with Makey, but they quickly progress to building and racing VexIQ robots and even programming microbit sensors using MicroPython. And the evolution of the tools they use is just incredibly rapid. Take a look at this jump. In just one single year, students upgrade from flying Codrone EDUs manually using visual Blockly chunks as engineers to writing authentic Python flight commands to control the exact same drone autonomously as innovators. This kind of rapid escalation guarantees they never hit a learning plateau. So imagine an 11-year-old at the Rank 6 Innovation Expo. While most adults out there are struggling just to format a spreadsheet, these kids are effortlessly walking you through a Python app they built, an artificial intelligence image classifier they trained using Teachable Machine, and a drone they just programmed to fly itself through a 3-waypoint autonomous route. It's wild. Next up is Section 4, ranks 7 through 9, Middle Explorers. Spanning years 7 to 9, where they earn the titles of technologist, architect, and pioneer, this is the point where outputs transition from standard classroom exercises to functional, public-facing projects. They aren't just learning isolated skills anymore, they're actively combining domains. Their new reality is all about solving real problems. We're talking launching live, multi-page HTML and JavaScript websites on public URLs. We're talking running 4-week, real-world social media campaigns complete with analytics. And they're even engaging in ethical hacking by completing formal capture-the-flag cybersecurity challenges on platforms like TryHackMe. The principle of escalation is really beautiful here, especially when you look at 3D printing. A student moves from printing a simple functional object to mastering tight tolerances for fit with a Fusion 360 multi-part assembly. And ultimately, they deliver a full Shark Tank-style pitch for a prototype, complete with a target customer, cost analysis, and a marketing plan. But before we look at the final division, you really have to ask yourself, what is left to teach a 14-year-old who has already achieved this level of technical mastery? Honestly, most standard curricula end right here. But in this architecture, this is merely the springboard. Which brings us to Section 5, ranks 10 through 12, the teen visionaries. In their final 3 years as strategists, specialists, and visionaries, these students achieve professional-grade mastery across all domains. We are talking about using industry-standard tools, GitHub for version control, TensorFlow for neural networks, and Kali Linux on Raspberry Pi devices for penetration testing. It is genuinely awe-inspiring to see high schoolers commanding tools at this level. I change the world. Living up to this massively ambitious theme, these teens are deploying real full-stack web apps with user authentication and databases. They're integrating OpenCV computer vision libraries so their drones can visually detect objects to launch sequences, and incredibly, they are submitting real bug bounty reports on platforms like HackerOne. Let that sink in. At the Ultimate Year 12 Capstone, a massive public event known as the annual wCode Summit, they present complex, cross-discipline projects to a panel of actual industry professionals. This includes a community builder project where they lead a real-world tech solution for a local school or nonprofit, which actually requires formal client sign-off. Finally, Section 6, the Ultimate Graduate Profile. Let's see what this all adds up to. When we put the beginning and the end side by side, the contrast is just staggering. At age 5, their very first touch is pushing sequence buttons on a plastic, screen-free robot mouse. By age 17, their exit achievement is writing automation scripts and deploying a full-stack data science application utilizing Python libraries like Pandas and NumPy. And look at the AI domain. They jump from basic browser-based image classifiers with just 3 categories at age 8 to building, training, and deploying actual neural networks as live web interfaces or API endpoints that other people can interact with by the time they hit high school. So as we wrap up this explainer, I want to leave you with this thought to ponder about the sheer limitless potential of a deeply structured technology education. If we stop treating technology as just a toy and instead treat it as a rigorous 12-ranked professional discipline starting all the way back in kindergarten, we aren't just teaching kids to consume the future. What are our children truly capable of building? Well, when given the right tools, we are giving them the exact blueprints to build the future themselves.